Okay, just like you can use Excel or MATLAB or Python, you can also use Mathematica to make plots of both functions and list or sets of data. So I'm going to quickly show you how to do both right now. Okay, so if you just want to make a plot of some mathematical function, the easiest way to do that is just to use the command plot. Again, it's capitalized, it's defined, which is why it's black, and I'm going to use square brackets to basically define what the inputs are. For the plot function, the first thing you want to input is the actual function you want to plot. In this case, I'm just going to plot the sine of x. And then here I am telling it what range of x I want to plot against. So I'm going to say x is the variable that's going to change in my plot. So this is what's going to be on the horizontal axis. And I want it to go from 0 to 4 pi. So I'm going to go ahead and shift return to execute that. And you can see here I do have a sine wave going from 0 to 4 pi. Okay. If I want to make a plot that has more than one function on it, that's easy to do. I just add my functions to the plot command and I add them as a list. So if you guys remember, lists are defined by curly brackets. So I've got curly brackets around the two functions that I want to plot. The thing separating them, or the delimiter, is a comma, and here I'm plotting the sine of x and the cosine of 2x over the range of x from 0 to 2 pi. Okay, so Mathematica automatically changes the colors of the lines so they look distinguishable. Okay, some other stuff I might want to do here is maybe I want to add a legend to my plot so I can distinguish between the lines if I'm maybe going to put this in a PowerPoint slide or something like that. Here's just one way to do that. Again, this is the exact same syntax I had before, but now I'm adding an option to the plot command, and there are many more, so you'd have to look at the documentation for all of them. But one that you can add is plot legends. Again, this is built in, so the way that you write this out has to be exactly how I wrote it out here, including the capitalizations. Okay, so for example, if I were to take the L and make it lowercase, notice that read stuff out, which means that's no longer a built-in command. Okay. And again, if I wanted to learn more, I can click on this arrow. But what I'm going to do here is I'm going to do plot legends. Again, I can get that little arrow by doing a dash and a caret. And then in quotation marks, I'm going to just put expressions. So what does that do? Now it actually uses the mathematical formulas I've defined here to write out the expressions, basically the thing that I typed in. And it looks pretty nice the way that it writes it out. Okay. If I would rather type in my own labels, this is an option for that. So again, just another built-in option for this plot legends command. I'm going to go ahead and just run this and show you what it does. Here you can see that now instead of having the functions, I just have blanks, and I can actually type in here myself what I want it to say. Okay, so that's another option to do. And then again, there's lots, just like MATLAB, there's tons of different ways you can manipulate your plot. You can change the line width, the line color, the markers, all kinds of things. So this is just another example. Again, I'm going to plot the same two functions. Here I've changed the range of x from 0 to 0.5 pi. I've added a label to my plot, so like a title. I'm giving this plot a frame, so that means it's going to have lines around the border. I'm going to label the frame with the axes label, so time and units of seconds on the horizontal axis, position and meters on the vertical axis, and then I'm going to go ahead and adjust the font size of everything that's a label. So plot label and then the frame label. So let's go ahead and run that and see what that looks like. Okay. So just to play around, maybe I'd look at my plot and be like, whoa, that font size's too big, so I can change it and rerun it, and that maybe looks more reasonable. Okay. If I wanted to save this plot, I can right-click on it to save it, and I can save it as a PNG or a JPEG or a PDF or something like that if I want to put it into another document. And I can also do quite a bit more if I play around down here with these options. If I want to change the background, Oh, that just changes the line. Let's see. What did I just do? If I want to change the background to white, that should work. There we go. Okay, so now it's got a white background. Here again, you can just mess around with this. I'll let you guys do that. But you can go down here as well. And notice every time I do something like that, it is going and using this number here to refer to this plot. So this plot is basically saved as an object that I can refer to as 39. So now it's saying, hey, show that same plot, but now let's change the axis style to white. Let's change the background to white. Okay. And so that's kind of nice because now I can actually, if I want, I can use the same syntax and come back to my original plot. And if I want it to work like that every time and the first time, I can just incorporate that in. Okay. All right. So that's how you plot functions just on a one-dimensional plot. So let's go down here and let's show you how to plot data or lists of data or actual points of data. Okay. So there's lots of ways to read in data or import data into Mathematica. We're not going to focus in on that too much, but the main way that I know how to do it is this read list command, and it is basically set up to read just text files that just have numbers in them. Okay, so in this case, I do have a text file in my computer with 2 columns of numbers, and that's what I'm going to plot. I'm going to show you a couple of ways to read that in. This first way, I'm going to use this built-in read list. Here, I'm giving it the full path on my personal computer where this file is. I'll show you in a second where you can maybe explore a little bit paths on your computer, but there's also other ways to do this. And then here, I'm basically telling Mathematica what this file format looks like. So in this case, it's like I said, it's just 2 columns of data. So I'm specifying that here. It's going to read in numbers are the data type, and it's going to be a bunch of rows with 2 values in it. Okay, so I'm going to go ahead and execute that. And you can see here what came out is a list within a list. So each of these individual sets of data points is a list. Okay, and then they also have this bracket notation on the outside of them. So data itself is a list of basically every single row that was in my data file. Okay, so that's one way to read it in. This is just some other syntax. If you want, you can figure out what directory your notebook is in. So in this case, I'm using the built-in command notebook directory with no input, so just square brackets to say, hey, what is the path of the current place where my notebook is running from or where I saved it? Okay, so this is where it is. And then this next command says, hey, let's set the directory that I'm running in. Okay, and in fact, I could just do, let me just show this before. Oh, I'm not going to be able to show that because I already said it. Well, basically, your notebook might not be running out of the same directory that your notebook was saved in originally, okay? So what I'm doing here is I'm saying, hey, let's set the current directory of the notebook, just like you might set your current folder in MATLAB to be the notebook directory, okay? So now, basically, when I'm referring to things in this notebook, it's looking first in the directory that the notebook is saved in. That data file happens to be saved in the same directory that the notebook is saved in, and so now I can read it in that way, okay? Just another way of reading it in, same set of data. Okay, you can also just manually type it in, right? But oftentimes when we're trying to plot data, we want to read in a big file, so it's nice to know how to do that. Okay, so if I want to plot lists of data or these values instead of plotting a continuous function, I need to use list plot instead of plot, okay? So list plot here is taking in data. Again, data has a form that looks like this, okay? So it is curly brackets around basically rows or individual couples of data or pairs of data. Okay, so I'm going to go ahead and run this. And here you can see I used a lot of the same things to change what my plot looks like as I would in the regular plot command. I gave it a frame, I gave it a frame label, which allows me to do axes labels, and I can change the size of the axes labels here. This is what my plot looks like. Okay, if I want to expand it within the window, I can. And you can just see those data points plotted as blue markers here by default on my plot.